Hello everyone, I am Tabish Abbasi, and in this particular video we are going to solve another problem on the topic of power cycle, which is a subtopic of number system. So without any further delay, let's get start the video. So as you can see, how many consecutive numbers from 50 should be multiplied to get 3 zeros in the last? Let me tell you what is the meaning of consecutive. The meaning of consecutive is of one after another. Let me tell you, 1, 2, 3, this is one after another. These all are consecutive. Okay, so 20, 21, 22, 23, these all are consecutive. If we talk about the consecutive odd, this is odd and this is also odd, this is also odd. So these all are odd consecutive. If we talk about the even consecutive, it will become 10, 12, 14. So we can say one after another is nothing but the consecutive. Okay, so let me clear this. Okay, now let's come on the question. It is saying how many consecutive numbers from 50 should be multiplied to get 3 zeros in the last. So it is basically saying that how many number we should multiply with 50 and those should be consecutive, and 50 into 51 into 53 into 54, it can go up to infinity, but it is saying that how many minimum possible number we should multiply, and we will start from 50. So the resultant value should get 3 zeros in the product of the resultant of these values. Okay, so let's talk about what is 0. 0 is nothing but 5 into 2. Okay, 5 into 2, which is equals to 10, but we are considering the unit digit here. Okay, so to solve these types of question, we have one method. So what we will do, we will start from 50. So as we can see, this is 50 and it is also have 1 0. So we will do the prime factorization of the 50, of this number which is 50. So 2 into 25, this is prime, so we can't divide it further. But 25 is not a prime number, so we can divide it 5 into 5. And as you can see, 5, 2, this is one pair. 5, 2, this is one pair. It means this number, this is the prime factorization of this number. It means if prime factorization contain 1 2 and 1 5, it means the value the number contain 1 0. Okay, so as we can see, this is the number 50 containing 1 0. Now let's try to multiply with 51. Let's check the prime factorization of this number. It will become 17 into 3. Okay, so we have one pair, 2 into 5. Now here we have another 5, so we will write 5 here, but we haven't 2, so we can find it in the another number, which is 52. Let's do prime factorization of this, and it will become 26 into 2, and 26 can divide it further, 13 into 2. So as you can see, we can make one pair from here. Okay, so 2. So we have 2 pair. So it means if we multiply 50 into 51 into 52, what will be the product of this number? Will contain 2 zeros. Okay, but we want 3 zeros. So we will check in the another number, which is 53. 53 is a prime number, so it will become 53 into 1. So we can't make another pair here, but we have another 2 here, so we can write it as here. So we need 1 5 till now. Let's check it in another number. 54 is nothing but 27 into 2. Okay, and 27 can divide it further because it is not a prime number. 9 into 3, 3 can be divided further, 3 into 3. But we do not have 5 in this number, which is 54. Let's check in the 55. So as you can see, 55 is nothing but 11 into 5. So we have 1 5 here. So it means if we divide if we multiply 50 into 51 into 52 into 53 into 54 into 55, so what will be the product of this? Will be contain 30 in the product of these numbers. Okay, so we can say that 1 2 3 4 5 6. So we have to multiply six consecutive numbers which will start from 50 to get the 3 zeros in the resultant in the product of those numbers. So our answer will be 6. So third option is the correct option. Thank you. Hello everyone, I am Tabish Abbasi, and in this particular video we are going to solve another important problem on the topic of power cycle, which is a subtopic of number system. So without any further delay, let's get start the video. So as you can see, this is our question. Okay, this question is based on the concept of the power cycle. Okay, so if you don't know the concept of power cycle, so it is recommended to you should know the concept first, and after that you should try to solve these types of question. Okay, so let's come on the question. So as you can see, this is our question. Which of the following is true? So here are 4 statements are written on our screen, and it is asking that which one of the option is true. So let's check all the options by one. Okay, so 9 raised to the power 11, which is greater than 11 raised to the power 9. Okay, so let me tell you, we should find out the power cycle of 9. So the power cycle of 9, which is nothing but 9 and 1. So let's check what is the power. Is power even or odd? If the power is even, so our value will be 9. And if the power is odd, if the power is odd, so the value will be 9. And if the power is even, so the value will be 1. So as you can see, 11 is an odd number. 11 is an odd number. So the resultant of this expression, so while we solve this expression, so some number will some resultant we will get something like this, and this will be our unit digit. So while we solve this, we will get the unit digit as 9. Okay, so now let's solve this. 11 raised to the power 9. So what is the unit place digit? Unit place digit is 1, and if the unit place digit is 1, so it doesn't matter what is the power. The resultant value of this question, if something like this x, and if here so the last unit digit will be always 1. Okay, so 9 raised to so 9 greater than 1. Yes, it is absolutely true. So it means our first option is the correct option. Okay, so now let's check 9 raised to the power 11, which is 9, and less than 11 raised to the power 9. As you can see, this is wrong option. Okay, so this is option, this is wrong option. 9 raised to the power 11 we have found out. So as you can see, this is 9 and equals to 1. No, this is not correct. Okay, and the none, this is also not correct. So our first option is the correct option. Thank you. Hello everyone, I am Tabish Abbasi, and in this particular video we are going to solve another important problem on the topic of power cycle, which is a subtopic of number system. So without any further delay, let's get start the video. So as you can see, this is our question, and let me clarify you, this question is based on the concept of power cycle. So it is recommended you to know the concept first, then try to solve these types of question. Okay, so let's come on the question. What is the unit digit in 7 raised to the power 95 minus 3 raised to the power 58? So this is the complete expression in the question. It has two parts. Okay, the first one and the second one. So we will solve the first part of this expression first. Okay, so 7 raised to the power 95. So as we know the concept of power cycle, so the power cycle of 7 is nothing but 7 9 3 1. Okay, so this is the power cycle of 7. Now let's try to divide the 95 by 4, because we have 4 elements in our power cycle, as we know the concept of power cycle. Okay, so 4 2 ja 8, it will become 1, and 4 3 ja 12, it will become 3. So our third element in the power cycle will be our answer of this expression. So what is the third element, which is also 3? So the resultant unit digit of this expression will be 3. Now let's try to solve this expression 3 raised to the power 58. So as we know the concept of power cycle, what is the power cycle of 3? Which is nothing but 3971. This is the power cycle of 3. 3971. Okay. So we have power 58. So we will also divide the power by 4 because we have 4 elements in our power cycle. So 4 1 ja 5, it will become 1, 8, 4 4 ja 16, it will become 2. So what is the second element in our power cycle, which is 9? So the resultant value of this part of the expression will be 9. So as we can see, we haven't solved. If we solve this expression, it will get absolutely large value. Okay. So I'm not saying that this is the whole answer of this expression. I'm saying the unit digit. Okay. So the unit digit of the resultant while we solve this is 3 and is of this expression is 9. Okay. So we can't minus, and the sign is minus. So we can't subtract 9 from 3. So we will take 1 carry from here. If I tell you something like this, we can't divide, we can't subtract 9 from 3. So we will take 1 carry from here. So it will become 13 minus 9, which is equals to 4. So 4 will be our answer, and which is the second option. Thank you. Hello everyone, I am Tabish Abbasi, and in this particular video we are going to solve another important problem on the topic of number system. So without any further delay, let's just start the video. So as you can see, this is our question. The unit digit in the product 784 into 617 into 917 into 463 is. So if you solve this particular question by using conventional math, like 784 into 617, it will give some result. So we will multiply that result with 917. It will also give some result. We will multiply that particular result with 463. It will give the final result. And after that, we will see what is the number at its unit place. And after that, we will simply can take the correct option. Okay. But we do not have enough time to solve these types of question. This is a lengthy process. If we solve this by using conventional mathematics, it is very lengthy process. Okay. So in the exam, we do not have enough time to do such types of things. Okay. So if we apply some basic observation into it, it is we can solve this question in just a moment. Okay. Let me tell you what is the trick. Okay. So we will simply find out what is the unit digit of this, which is 4, into what is the unit digit of this, which is 7. What is the unit digit of this? 7. What is the unit digit of this? 3. So if we multiply both, 7 4 ja 28. So we will, what is the unit digit of this is 8. Okay. So 8 into 7. What is the resultant will be 56. What is the unit digit of this? 6. 6 into 3, which is 18. And what is the unit digit of this, which is 8? And we can say that 8 is the correct answer and our first option is the correct option. Thank you. Hello everyone, I am Tabish Abbasi, and in this particular video, we are going to solve another problem on the topic of power cycle, which is a subtopic of number system. So without any further delay, let's get start the video. So as you can see, this is our question. So let me clarify you, if you don't know the concept of power cycle, you should not able to solve these types of questions, okay? So it is recommended to you, you should know the concept first, then try to solve these types of question, okay? So let's come on the question. Find the units place of 253 raised to the power 96 and so on, okay? So let's try to solve this part of the expression first, okay? So as we know the concept of power cycle, we will find the power cycle of 3 because the resultant unit digit of this expression will depend on the unit digit of the base, and this is our base, this is exponent. So we have to find the power cycle of 3, which is 3971, okay, and it is raised to the power 96. So we will divide 96 by 4 because we have 4 elements in our power cycle. 4 2 ja 8, 9 minus 8 which is 1 and 6, 4, 4, 16. It will become 0 because we have a remainder as 0. It means the last element of our power cycle will be the answer of this part of the expression. Okay. So the answer of this will be 1 plus. The sign we will denote as it is. Now let's try to solve this expression part now. 26 raised to the power 23, as we know the unit digit of the base is 6. It means the power can be anything. The unit digit of the whole expression will be 6. Okay. Minus 104 raised to the power 99. So we have to find the power cycle of 4, which is 4 6. And let's see what is the power. Power is 99, which is an odd number. Okay, which is an odd number. If the number is odd, so the power will be 4. If the number is even, so the power will be not power. The result will be 6. Okay. So as we can see, the power is odd. It means the result of this, the resultant unit digit of this expression will be 4. Okay. Now plus, we will denote the sign as it is. 72 raised to the power 86. Let's try to solve this part now. So we have to find the power cycle of 2, which is 2, 4, 8, 6. Now let's divide 86 by 4 because we have 4 elements in our power cycle. 4 2 ja 8. It will become 6. 4 1 ja 4. It will become 2. So our remainder is 2. It means the second element of our power cycle, which is 4. So the result of this expression part is 4. Now we will extract the unit digit from this number, which is 7. Okay. Now 1 plus 6, which is 7. And we have minus sign here. Okay. So as we can see, it will become 7. It will become 7. And as you can see, this is minus 4, this is plus 4. So both 4 will get cancelled out, and it is plus 7 and it is minus 7. So both will get cancelled out. So answer will be 0. And we have 0 in our option. So our second option is the correct option. Thank you. Hello everyone, I am Tabish Abbasi, and in this particular video, we are going to solve another important problem on the topic of number system. So without any further delay, let's get start the video. So as you can see, this is our question. Find the unit digit of 177 into 105. So while if we solve this question by using conventional mathematics, so what will be the step? Firstly, we will write something like this: 177 into 105. And while we will solve this, we will find some resultant, and this rightmost digit will be the unit digit. So while we do the complete product of this number, and in the product we will see, oh, this is the unit digit. Let's suppose this is, I'm not exactly telling what is the unit digit. Let's suppose the unit digit you found that 1. So you will tick the 1 as an option. Okay, but it will take your time. It will consume your time. What if I told you the shortcut trick to solve these types of question? Okay. So the shortcut trick is nothing but you have to find out the unit digit of this number, which is 7. You have to find out the unit digit of this number, which is 5. So simply you have to multiply both. 7 into 5, which is 35, and what is the unit digit of 35, which is 5. So it is so simple. The second option is the correct option. So this is the power of aptitude. Okay. So our second option is the correct option. Thank you. Hello everyone, I am Tabish Abbasi, and in this particular video, we are going to solve another important problem on the topic of power cycle, which is a subtopic of number system. So without any further delay, let's get start the video. So as you can see, this is our question. Find the unit digit of the expression. As I told you, the question is completely based on the concept of power cycle. So if you don't know the concept of power cycle, it is recommended to you. You should know the concept first, then try to solve these types of questions. Okay. So let's come on the question. Find the unit digit for the expression 53 raised to the power 14, 98 raised to the power 19. Okay. So this is the complete expression, and we can say that this is the first part of the expression and this is the second part of the expression. So we will solve the first part of the expression first. Okay. So as we know the concept of power cycle, we have need to find out the power cycle of 3, because we know the concept of power cycle. Okay. So 3, what is the power cycle of 3, which will be 3971. So as we can say that we have 4 elements in our power cycle. So we will divide the power by 4. So it will become 4 3s are 12. So what is the remainder? Remainder is 2. It means the second element of the power cycle, which is nothing but 9, it will be the answer of this expression. 53 raised to the power 4. The answer of this expression will be 9. The unit digit of this expression will be 9 basically. So 9, 8 raised to the power 19. Let's try to solve this part of the expression also. So as we know the concept of power cycle, we have need to find out the power cycle of 8, which is 8, 4, 8, 4, 2, 6. This is the power cycle of 8. Okay. Now as we have 4 elements in our power cycle, so we will divide the power by 4. So it will become 4 4 just 16 and it will become 3. It means the third element in our power cycle will be the answer, will be the unit digit of the resultant of this expression. So the answer will be 2. Okay, so 9 into 2, which will equals to 18. And what is the unit digit of 18, which is 8. And as we can see, 8 is in our option. So it means second option is our correct option. Thank you. Hello everyone, I am Tabish Abbasi, and in this particular video we are going to solve another important problem on the topic of power cycle, which is a subtopic of number system. So without any further delay, let's get start the video. So as you can see, this is our question. Find the unit digit for the expression 23 raised to the power 24, 25 raised to the power 26 and so on. Okay. So let me clarify you, if you don't know the concept of power cycle, you should not be able to solve this question. Okay. So you have to learn the concept first, and after that you can try to solve these types of question. Okay. So let's come on the question. Find the unit digit for the expression 23 raised to the power 24. So we will try to solve this part of the expression first, 23 raised to the power 24. Okay. So as we know the concept of power cycle, the first step will be to find out the power cycle of 3, because our base unit digit is 3. So power cycle of 3 is nothing but 3971. Okay. As we have 4 elements in our power cycle, so we have to divide 24 by 4 and it will become 4 6 24. So the remainder is 0. If the remainder is 0, it means the last value of the power cycle will be the answer, and which is 1. Okay. So we have successfully solved this part of the expression. Now let's try to solve the another part, which is 25 raised to the power 26. And it is already solved, because we know if the base unit digit is 5, it means the resultant will be 5, and the power of the base, it doesn't matter if the unit digit of the base is 5. So the resultant will always be 5. Okay. Into 27 raised to the power 28. So as we know the concept, we have to find out the power cycle of 7, and the power cycle of 7 is nothing but 7931. 7931. This is the power cycle of 7. So as we have 4 elements in our power cycle, so we will simply divide the power by 4. So it will divide 4 7 28. So the remainder is 0. If the remainder is 0, it means the last element of the power cycle will be the answer, which is 1. Okay. Let's denote the sign as it is. Now let's try to solve this part of the expression. As we know, the unit digit is 9, so we have to find out the power cycle of 9, which is nothing but 9 1. If the power is odd, it means the value will be 9. If the power is even, it means the value will be 1. And as we can see, the power is even, it means the value will be 1. Okay. So 5 into 1 into 1 into 1. So the resultant will be 5. And as we can say that the result will be 5, and the first option is the correct option. Thank you. Hello everyone, I am Tabish Abbasi, and in this particular video we are going to solve another important problem on the topic of power cycle, which is a subtopic of number system. So without any further delay, let's get start the video. So as you can see, this is our question. Find the rightmost digit of the number 30 raised to the power 2860. Okay. So let me clarify you. If you don't know the concept of the power cycle, you will not be able to solve this. Okay. So it is recommended to you. You should know the concept first, and after that you should try to solve this question. Okay. So let's come on the question. Find the rightmost digit of the number 30 raised to the power 2860. And as we know the power cycle concept, it means if the unit digit is 0 in the base, so it doesn't matter what is the power cycle, so the resultant value will be always 0. So our second option is the correct option. Thank you. Hello everyone, I am Tabish Abbasi, and in this particular video we are going to solve another important problem on the topic of power cycle, which is a subtopic of number system. So without any further delay, let's get start the video. So let me clarify you. This question is based on the concept of power cycle. If you don't know the concept, so it is recommended to you. You should know the concept first, and after that you can try to solve these types of question. Okay, let's come on the question. So as you can see, the question is find the rightmost value of 7 raised to the power 13 raised to the power 21 raised to the power 11. Okay. So first we will solve this part of this question. Okay. So let me tell you what is the power cycle of 7, which is 7, 9, 3, 1. Okay. So this is the power cycle of 7, because the unit digit of this whole expression is completely dependent on the base, on the ones digit of the base. This is our exponent, this is our base. So because in this example this is a single digit number, so this is a ones place digit. Okay. So we will see the power cycle of ones place digit in the base. Okay. So base here is 7, and it is also on the ones place. So the power cycle of 7 is 7931. So we will take, this is our power, this is our exponent. So we will divide the power by 4, because how many elements are present in our power cycle are 4. So we will divide the power by the number of elements. So what is the remainder? Remainder will be 1. Okay. We will not consider the quotient here. We will only consider the remainder. So remainder is 1. It means the first place element, the first element will be our answer of this expression. Okay. So 7 is on the first place in our power cycle. Okay. So the result of this expression is 7. Now let's consider another. So as you can see, now the expression is 7 raised to the power 21. Now divide 21 by 4, because 4 elements are present in the power cycle. So 4, it will become, the remainder will be 1. As I told you, we will consider the remainder here, not the quotient. So the first number in the power cycle, which is also 7. So the result will be 7. Now we will consider this expression now, 7 raised to the power 11. So 7 raised to the power 11. So we will divide the power by 4, as I told you, because we have the 4 element in our power cycle. So what will be the remainder? Remainder will be 3. So as you can see, the result of this expression will be 3, and our final result will be 3. And the third option is the correct option. Thank you. Hello everyone, I am Tabish Abbasi, and in this particular video we are going to solve another problem on the topic of power cycle, which is a subtopic of number system. So without any further delay, let's get started the video. So as you can see, this is our question. Find the number of zeros in the last of the resultant. Okay. So basically it is saying if we multiply 57 into 39 into 89 into 71. So definitely we will have a product. Okay. So while we will solve this, definitely we will have a number as a product. Okay. So it is basically asking how many zeros in the product. Okay, how many zeros in the last of the product. So if we solve this question by conventional mathematics, like 57 into 39, it will give something, into 89 it will give something, into 71 it will give something. Okay, and after that we will able to see how many zeros in the last of the product. Okay, and as you can see, this is the lengthy process and we do not have enough time to do such types of thing in the exam. Okay, so we have a concept. So let me tell you what is 0. 0 is nothing but 5 into 2. Okay, if I tell you 50, and if I want to know how many zeros in this, so simply I will make the prime factorization of this. Okay, so 2 into 25 and 5 into 5. So as you can see, we have a pair of 2 5. 2 into 5, we have a single pair of 2 5. Okay, it means if a number prime factorization have a pair of 2 5, it means that particular number contain a 0. Okay, so 0 is nothing but 2 5. So now if you want to solve this question, we have to find out the prime factorization of all these numbers, and it is very simple. So what we will do, the prime factorization of 57 is nothing but 19 into 3, and as we can see, we do not have 5 and 2 in it, so it means no one 0 will be available in this number. Okay, so let's try to check 39. So the prime factorization is 13 into 3. Okay, so no one 0 into it. 89, so it is a prime number, 89 into 1, so no one 0 in this. 71 is also a prime number, so no one 0 is available in this. It means we can say, while we solve this, while we multiply these numbers with each other, so the final product does not have any 0. So basically it is asking how many zeros, so we can say 0 zeros will be available in the product. Okay, so our second option is the correct option. Thank you. Hello everyone, I am Tabish Abbasi, and in this particular video we are going to solve another important problem on the topic of power cycle, which is a subtopic of number system. So without any further delay, let's get started the video. So as you can see, this is our question. Find the number of zeros in the last of the resultant. 55 into 42 into 85 into 70 into 26. Okay, so if we try to solve this question by using conventional mathematics, which is something like this: 55 into 42, it will give some result to us, and we will multiply that into 85, it will also give some result, into 70, it will also give some result, into 26, and after that this will be our final step and we will get our resultant, and we can check how many zeros in our product and we can tick the correct option. Okay, but it is a lengthy process. Okay, and in the examination we do not have enough time to do such types of things. Okay, because aptitude exam is really tough exam. Okay, so we have to find the another approach to solve these types of question very easily and in very little amount of time. Okay, so let me tell you. Let's observe a thing. What is 0? 0 is nothing but 5 into 2. 0 is nothing but 5 into 2, which is 10. Okay, so what we will do to check how many zeros in the product of these numbers. Okay, so we will simply find out the first step. We will find out the prime factorization of each number, and to find prime factorization, it is very easy. And while we have prime factorization, we will check if there we are making any pair of 5 2, and as many pair of 5 and 2, so as many zeros will be there. Okay, so what is 55? What are the prime factorization? Which is 11 into 5. This is the prime factorization, and we have 1 5 here. Okay, now let's try to what is the prime factorization, which is 21 into 2 and it is 7 into 3. Okay. Now let's try to find out the prime factorization of 85, and what it will be. It will be 7 into 5. Okay. So now let's try to find out the prime factorization of 70, which is 10 into 7 and 2 into 5. Okay. Now let's try to find out the prime factorization of 26. It will be 13 into 2. Okay. Let's find out how many pair are visible here. So it is 1 5, so we will write 5. Now let's try to find out 2. So we have 2. Okay, so it is 1 pair. Now is there any 2 or 5? Yes, we have another 5 more, so we will write 5, and we have 2 here, so we will write 2. So this is second pair, and we have 5 here, so we will write 5. Is there any 2? Yes, we have 1 2 here. So we have 3 pair. It means 1 0 2 0 3 0. So it means that while we multiply these numbers with each other, so there will be definitely a product. So in the product, in the last we have 3 zeros in the product, and as we have 3 is in the option, so we will simply tick on the fourth option, because 3 is the correct answer. Thank you. Hello everyone, I am Tabish Abbasi, and in this particular video we are going to solve another important problem on the topic of power cycle, which is a subtopic of number system. So without any further delay, let's get started the video. So as you can see, this is the question: find the number of zeros if 5 consecutive numbers are multiplied starting from 21. Basically it is saying that, let me tell you first what is the meaning of consecutive. Consecutive is nothing but the one after another. As you can see, 1 2 3 4, these all are consecutive, and 1 5 3 2 4 2, these not are consecutive. Okay, so 2 3 1 2 3 2 2 3 4 231 232 234, because it comes after this, it comes after this. So these all are consecutive, these all are consecutive, and the sequence is incorrect. So it means these all not consecutive. Okay, these all are not consecutive. So let me clear this first. So as we know the what is consecutive number, so it is saying that find the number of zeros if 5 consecutive number are multiplied starting from 21. It is saying that if we multiply 20, if we start from 21, we have to multiply 5 number. So 1 2 3 4 5. Okay, so 21 into 22 into 23 into 24 into 25. It is saying that if we multiply these numbers, so what will be the product? If the product something like this, so something will be the product. So it is asking how many zeros in the product. Okay, so if we do something like this, 21 into 22, then something will be the result. Then we will multiply this by 23, something will be the result. Then multiplied by 24, then will be the result. Multiplied by 25, then will be the result. And after that we will check how many zeros are in the product. So it is too lengthy method, and it will consume a lot of time, and in the exam we do not have a lot of time. Okay, so we have need to find the trick. Okay, so it means, let's suppose if this is 21, not suppose, it is actually 21. Okay, so to find out how many zeros will be in the product of these numbers, so we will do the prime factorization of each number. 21 is 7 into 3. Okay, this is the prime factorization of 23. Now 22, which is 11 into 2. Okay, now 23, which is a prime number, 23 into 1. Now 24, which is 12 into 2, and 2 into 6, and 3 into 3. Okay, now 25, it will become 5 into 5. Now let's take out, if we make the pair of 5, 2, how many pair of 5, 2 are in these all prime factorization? Because 0 is nothing but 5 into 2, which is exactly 10, but we have to find the zeros, okay? So as we can see, this is 1, 2 here, so we will write it here, okay? Now we have to find 1, 5. So as we can see, this is 1, 5 here. So it means if we multiply these numbers, it is definitely we will get 1, 0, okay? Now let's try to make another pair if it is possible. So here is another 2, 2 into, let's try to find out another 2, another 5. So it is 5 here. So it means, is there any 5? Yes. Is there any 5? No. Is there any 2? Yes. So we will write 2 here. Is there any 5? No. So we will cancel out this. It means we have 2 pair of 2 into 5. It means if we multiply these all numbers with each other, so the product will contain 2 zeros. Okay. And we have 2 in our option. It means second option is the correct option. Thank you. Hello everyone, I am Tabish Abbasi, and in this particular video we are going to solve another important problem on the topic of power cycle, which is a subtopic of number system. So without any further delay, let's get start the video. So as you can see, this is our question. It is based on the concept of power cycle. If you don't know the concept of power cycle, you should learn that concept first and try to solve this question after that. So let's come on the question. Find the last digit of 1, 2, 3 x 568 plus 856 minus 256 into 23. So it is basically asking the last digit. Okay. So we will take out the last digit of from all of these number. So 3 into 8. Okay. The sign is plus. And what is the unit digit of this? Which is 6 minus 6 into 3. Okay. So 3 into 8, which is equals to 24, plus 6 minus 18. Okay. So 24 plus 6, which will be 30 minus 18. It will become 12. And what is the unit digit of 12? Which is 2. So as we can see, 2 is another option. So our correct option is third option. Okay. So 2 is our answer. Thank you. Hello everyone, I am Tabish Abbasi, and in this particular video we are going to solve another important problem on the topic of power cycle, which is a subtopic of number system. So without any further delay, let's get start the video. So as you can see, this is our question. So let me clarify you, this question is based on the concept of power cycle. So it is recommended to you, you should know the concept of power cycle first, then you should try to solve these types of question. Okay, so let's come on the question. So the question is saying that find the last digit 21 raised to the power 11 plus 22 raised to the power 12 plus 23 raised to the power 13 and so on. Okay. So our options are 6, 1, 3, 5. So the question is looking hard, but it is not if you know the concept of power cycle. So let's try to solve this part of this expression first. Okay. So as we know, the result of this expression is completely dependent on the unit digit of the base. This is our base, this is our exponent. Okay. So the whole result of this expression, of this part of the expression, this part of the complete expression is completely dependent on the unit digit of the base. This is our base. So if the unit digit of base is 1, so the resultant value, the unit digit of the resultant value will always be 1. If the power does not matter, what will be the power? It doesn't matter if the unit value is 1. Okay. So the resultant of this, the resultant unit digit of this expression part will be 1. Okay. So now let's try to find out the power cycle of 2. So the power cycle of 2 is nothing but 2, 4, 8, 6. Okay. Now what is power? Power is 12. Now let's divide the 12 by 4 because we have 4 elements in our power cycle. and it will completely divide. Okay, so what will be the remainder? Remainder will be 0. So let me tell you, we will consider the remainder here, not the quotient. So if the remainder is 0, it means the last digit which is in our power cycle will be the answer. Okay, so the 6 will be our answer of this expression part. Okay, so now try to solve this expression part. 3 raised to the power 13. So what will be the power cycle of 3? 3 and 9, 7, 1. Okay, so this is the power cycle of 3. Now let's try to solve this. What is the power of this expression? The power is 13. So let's divide the power by 4, because we have the 4 element in our power cycle of 3. So 4, 3 is 12, so the remainder is 1. If the remainder is 1, the answer will be the first element of our power cycle, which is 3. Okay, so as it is, we will denote this sign as it is. Okay, so now let's try to solve this part of this question. So it is 4 raised to the power 14. Okay, so let's try to find out the power cycle of 4, which is 4 and 6. Okay, so this is the power cycle of 4. If the power of this expression is odd, so the resultant will be 4. If the power of this expression is even, so the answer will be 6. Okay, so as you can see, 14 is an even number, so our answer will be 6. Okay, now let's try to solve this expression, and we do not have need to solve this expression, because if the unit digit is 5, so it doesn't matter what is the power, the resultant value will be always 5. Okay, so we will denote the sign as it is. Now let's see, 6 1 is 7, 7 3 is 10, 10 6 16, 16 and 5 21. As we have the total result is 21, and what is the unit digit of 21, which is 1. So as we can see, 1 is in the option, so the option second is the correct option. Thank you.